Hi, welcome to video 8 of linear relations video set. Today we're going to be talking about X and Y intercepts. And so just to get started with this, I'm going to start by taking a look at the grid, just as it is. And we need to become aware of a couple of things that are very important here. So first of all, I'm going to draw or plot some points here. So I'm going to plot some points along the y-axis, first of all, right on the y-axis. And then we're going to get the ordered pairs of these points. And I'll plot a couple down here as well. Okay, so the very first point here that I plotted was has ordered pair 0, 0. What would this next ordered pair be if we know that the ordered pairs are in the specific order, the pair of values, pair of coordinates that are in the specific order of x, y, x followed by y. So starting at the origin, if we go no direction in the x, but then we go up one direction in the y, what's the ordered pair there? Okay, so that would be 0, 1. The next one above that, of course, again, we're starting at the origin. We're not going in the x direction at all. We're just going straight up in the y direction. And we're going up 2 units. So we're going 0 in the x and 2 in the y. And then we just follow that pattern. We go 0 units in the x direction and then 3 in the y, starting from the origin, etc. And then we just keep going up here. So here are the first few ordered pairs of these specific points that are plotted on the y-axis. And then we go down into the negatives, the same idea. We start at the origin. We don't go in any direction in the y or in the x direction. So we're going 0 units in the x, but we are going down 1 unit in the y. And then, of course, same sort of thing, we go down 2 units in the y direction. So you probably would notice here the value that we see common here in every one of these points. So if we know that every single point on this, on the y-axis, has the x-coordinate of 0, then we can summarize every single point on the y-axis as, and I'll put this in red to emphasize it, as x equals 0. So that actually becomes the equation of the y-axis. So the y-axis is, or has the equation, x equals 0. Okay, so that's going to be important. Now if we do the same sort of thing along the x-axis, and we plot points along the x-axis in the positive direction, and then we plot some points in the negative direction as well. And then we go about and find the ordered pairs. Well, starting at the origin, again, 0, 0, we go 1 unit in the x direction, the positive x direction, but we go 0 in the y direction. Then if we go back and we start at the origin and we go 2 units in the x direction, but 0 units in the y direction, then we get the ordered pair 2, 0. And then again, starting at the origin, we go 3 units in the x direction and 0 in the y direction, etc. So all these ordered pairs are increasing with the x coordinate, but the y coordinate is staying constant. And then over here in the negative side of the y-axis, we go starting from the origin, we go -1 in the x direction and then 0 in the y, and then -2 in the x, 0 in the y, etc. Okay, so here are the coordinates of all those ordered pairs that I plotted along the x-axis. And then, of course, again, if we were to take a look at the ordered pair, or the coordinate that doesn't change, the coordinate that's the same in every single one of these points, we see that that is y equals 0. And as it turns out, every single point along the x-axis will have a y coordinate of 0. So therefore, the x-axis has the equation y equals 0. Okay. So now I'm going to move on to the next portion of this. So now that we've established that the y-axis has an equation of x equals 0, and the x-axis has an equation of y equals 0, meaning that every single point on the y-axis has an x-coordinate of 0, and every single point along the x-axis has a coordinate of y equals 0, then if we're to take a look at a line that's given to us here, we see that it's sloping down to the left. Remember that from past videos, we always follow a graph from left to right. And we see that this one is going down as we go to the right. So this means that it has a negative slope. Okay, just to kind of bring back a little bit of learning from the past. So this line has negative slope. We see that it has a y coordinate of, or sorry, y-intercept of 0, 6, and we see that it has an x-intercept. We can call this an x-intercept now, being that it is where the graph crosses the x-axis, and that x-intercept has coordinates of 8, 0. Okay, so that's easy enough to kind of see from a graph. But what if we were just to give an equation? So if we were given an equation, and in this case, this graph actually has the equation 6x plus 8y equals 48. And we'll get into that shortly as well. But this equation, this graph, has the equation 6x plus 8y equals 48. Well, how would we go about doing that algebraically? How would we find the x and y intercepts? Well, it's fairly straightforward, and it's a pretty standard routine. We know that if we're like trying to find the x-intercept, we know that every point, every ordered pair along the x-axis has a y-coordinate of 0. Okay, so we just looked at that. So then we'd say, okay, well, for the x-intercept, we know y equals 0. So then if that's the case, then all we have to do now is substitute 0 in for the y of these equations. So we've got 6x plus 8y, or sorry, and 8y, the y coordinate is 0. Okay, and 8 multiplied by 0, well, anything multiplied by 0 is just 0. So we end up getting 6x plus 0 equals 48. Now that 0, we don't really need to add that. We don't really need to show that because 6x plus 0 is just still 6x. And that still equals 48. And then you have to figure out what value of x would give us 48 when multiplied by 6. Okay, so we can do it algebraically, or we can just kind of do a little thought in your head. 6 times what number gives me 48? Well, then I know that's going to be, x is going to equal 8, because 6 times 8 is 48. If you wanted to do it algebraically, we say, well, if 6 multiplied, we know this is multiplication. 6 multiplied by x is 48. Well, then if I divide both sides by 6, to leave me that 6 over 6 is just a fraction. We know that 6 over 6 as a fraction just equals 1. So then 6 over 6, that just equals 1. And those 6's kind of just disappear. They dissolve into thin air, and that just leaves us with 1x, and 48 divided by 6 is 8. So then the ordered pair here for the x-intercept, the ordered pair here is, well, we just found that x is 8, and we knew that y was 0, so the ordered pair for the x-intercept is 8, 0. Okay, and then we can do the same thing over here for the y-intercept. We can say, well, for the y-intercept, we saw before that every point along the y-axis has an x value of 0, an x coordinate of 0. So I'm going to state that x equals 0 here, and then I'm going to substitute that into the equation and leave the rest of the equation alone. So 6 multiplied by 0 plus 8y equals 48. Well, 6 times 0 we know is just 0. Again, we don't need to write that because 8y plus 0 is just still 8y. And so 8y equals 48. And then again, we can say, well, 8 multiplied by what is going to give us 48? And 8y, well, we know that 8 multiplied by 6 is 48. And again, algebraically, what we could do is we could just divide both sides by 8 because we know that 8y is just 8 times y, and 8 over 8 as a fraction is just 1. So those dissolve into thin air and leave us with y equals 6. And then the ordered pair, well, we know that x equals 0. We already stated that before. So the ordered pair is 0, and the y that we just found is 6. So algebraically, if we're given an equation in this form, this is called intercept form, a form that we haven't really looked at before. If we find the x and y intercepts algebraically, this is how we would do it. Substitute y equals 0 into the equation, and we're left with just 6x equals 48, and then solve for x to get 8, 0. And for the y-intercept, we substitute x equals 0 into the equation to leave us with 8y equals 48, and that gives us y equals 6. So then the ordered pair for the y-intercept is 0, 6. So we can go up here and verify that 0, 6 is the y-intercept, and 8, 0 is the x-intercept, as seen in the graph, and as we have calculated this algebraically. Okay, let's take a look at a couple other quick examples. Here's the equation 4x plus 6y equals negative 24. See, the graph is not drawn in the grid this time. So now we're going to use the intercepts to draw the graph. So if the equation is given in this form, I always find it easiest to find the x and y intercepts. Okay, and from before we know that for the x-intercept, every y coordinate on the x-axis is 0. So I can just substitute 0 in for 6y. So, and 6y times, or 6 times 0 is going to be 0. So I'll just do that in this case here. So 6 times 0 is 0. So 4x plus 0 is just 4x. So 4x equals negative 24. And then if I divide both sides by 4, I get x equals negative 6. So the ordered pair then is negative 6 and 0. And then for the y-intercept, I know that x equals 0 because every point along the y-axis has an x-coordinate of 0. And then I'll do the same thing here, substitute 0 in for x, and leave the rest of the equation as it is. And then so I end up getting 6y equals negative 24. Divide both sides by 6, so y equals negative 4. So then the ordered pair is 0, negative 4. There's 0 because x is 0 on the y-axis, and negative 4 because we just calculated that. So now I'll just plot these 2 points. Negative 6, 0 is the x-intercept. So I plot that point right here. That's negative 6, 0. And the y-intercept is 0, negative 4. So I'm going to plot that point right here. And then I'm going to draw the line between those 2 points. And we always extend the line as well. Okay, so I'm going to draw the line and extend it past those, and we put an arrowhead on the head of the line. So I'm going to just draw this down here like this, and then I'm going to draw it in the opposite direction as well, just so I can aim it well. So I'm going to come along here. So I kind of missed the x-axis there, or the x-intercept a little bit, but that's basically the way the graph would be drawn for that equation. Okay, so this equation of this line, as we can see up here, is 4x plus 6y equals negative 24. All right, let's take one more example here quickly. Here's another example, 6x minus 4y equals 12. We've got the empty grid here waiting for us. So what I'd like you to do, could you please pause the video and find the X and Y intercepts using the pattern that we did previously, and then come back to the video to watch the solution. Okay, so now that we've done that, for the x-intercept, what did you set the y value to be? Okay, that's right. Anywhere along the x-axis, y is 0. So then when we substitute y equals 0 into here, we're just left with 6x equals 12. We know 6 times 2 equals 12, so that means x equals 2. And what would the ordered pair be of the x-intercept then? Okay, that's correct. That would be 2, 0. And then for the y-intercept, we know that the y-intercept, the x-coordinates of all the points on the y-axis are 0. We substitute 0 in for x. We're left with then negative 4y equals 12. And then we divide both sides by negative 4, or we multiply negative 4 times something to give us positive 12. Well, we know a negative multiplied by a negative will give us a positive, so y is equal to negative 3. Or otherwise, if we divide both sides by negative 4, a positive divided by a negative will give us a negative. And then the ordered pair for the y-intercept is going to be 0 for the x and negative 3 for the y. Okay, and then we can just go down here and plot these. So 2, 0 is the x-intercept, and then 0, negative 3 is the y-intercept. And then we'll draw the line between the 2 points, and we'll extend the line. Okay, so this is going to go up through here and extend the line, and then we're going to have the next part of it. I'm going to draw it from here. Okay, so the line is going to look like that. Okay, so that is a quick example of how to use X and Y intercepts to graph a line on a grid. Thanks for watching, and we'll see you in the next video.